Okay, exam two, part two. This is a review of the answers that you folks gave. And collectively, I've given you each feedback via comments within the assignment for part two. And I'm also putting together this video for everyone. So we're all working with the same information. Remember, there's a video from part two, exam one, and I know some of you still have not watched that, so please go back and watch that one because each time we do an exam, the idea is that you're able to better zero in the type of information I'm looking for as I'm reading your answers. And I want you to be successful. And so the first exam I did not grade and I gave some feedback individually as well as collectively. This time I did include a grade and I also have provided the individual feedback and I'm also doing this graded or group feedback and realize that the expectations keep going up each time we do this. So part two, exam three, the expectations will be even higher that we're zeroing in on the type of answer I'm looking for. Granted, I may not be asking the best question, but that's why I didn't grade the first one and I gave you some feedback and I'm giving some feedback now is so that we can find that avenue that you're answering questions in a way that is easy for me to look at and understand the level of knowledge you have on a particular area. So remember, exams are all about your ability to demonstrate a level of knowledge on the topic of that exam. And so really the questions I'm giving you are open-ended, they're vague. That's graduate school. It's graduate work because I want you to really think about the questions and provide an answer given the context of the content we're covering for that exam. Remember, I've already divulged part of the final exam will be why does someone collapse at the end of an iron distance event? And so you already know what the question is. So now you're building up information to be able to answer that type of question. There's no single answer. There's no right answer. It's not the same answer for every athlete that has collapsed at the end of an iron distance event or crawled across the finish line. What this course is about is trying to discover and understand different mechanisms that ultimately limit performance or would lead to something like collapsing. And we're really taking a physiology based approach to answering that. In the biomechanics of endurance course, then we take a biomechanics perspective of, in essence, the same question or same project questions that you may even be working on. And that's good because sometimes we want to start in a particular area, but ultimately we will when even you leave this class and as you continue to work on your degree, you need to incorporate all areas of kinesiology, exercise science, nutrition. You gotta incorporate all the different sub-disciplines in order to understand endurance performance. All right, so I just want you to keep in mind a few key bullet points as you write the next part two for exam three. One, this is an opportunity for you to demonstrate your level of knowledge. All right, keep that in mind. I'm reading these answers and trying to see if you're understanding the content that we're going through based upon the question and based upon the answer that you're providing. So make it easy for me in terms of evaluating your level of knowledge. I also highly value, and the department highly values in the graduate program especially, is that your answers are based upon empirical evidence. There's a lot of anecdotes out there in terms of the types of questions we deal with. And those anecdotes may be helpful, but at the end of the day, we need to dive into the peer-reviewed research on a topic to really provide a graduate level answer to some of these questions. It's not easy because sometimes you get conflicting information. And conflicting information is not a bad thing, but it is good to identify when literature conflicts with each other and then even explore some of the reasons why there may be a conflict. But I want your answers to be research based. not anecdotally based. I want them to be based upon the research that's out there. You don't always have to agree with the research, but you need to base your answer on the research. And if you disagree with the research, what you would do is talk about the limitations of a study or the experimental approach that maybe provided some information that wasn't accurate. You see Noakes doing this all the time in the textbook. He's challenged the value of VO2 max. He's challenged this observation of a plateau phenomenon in VO2. He challenges the importance of lactate threshold, and even has proposed different naming of that threshold. So there's, the book is a good example of looking at the empirical evidence, but then giving some reasons as to why someone may not agree with the evidence that's been presented. So citations, citations, citations. I really want you to focus on the next part 2 on making sure that you're providing references beyond the textbook, beyond the lecture notes, and looking at the primary sources. These are the sources that provide a description of an experiment that the authors did. Now remember, Noakes will refer to some literature, and that's good to go and look some of those citations up. Don't rely only on his interpretation of the literature when he does present primary source information, and go find that primary source and read it for yourself. There are several instances in literature reviews or secondary sources that provide an interpretation that you may not agree with on a primary source. So I really want you to be thinking about including citations on your next part 2. And many of you did that in this part 2, and that was excellent. I'm going to point that out. But continue to build on that. And you want to make sure that you're finding primary sources as well from peer-reviewed journals. And I don't want to lose sight that I'm looking for succinct, clear, and accurate answers. Longer is not better. Too short sometimes is not helpful because so far when the answers have been really short, they're usually very, they aren't going deep enough with an answer. And it's hard for me to get a sense as to whether or not you're picking up on some of the concepts that we're going through. So I don't want to lose sight though, that I still want you to be succinct. I still want you to be clear, and I want you to be accurate as well. Let me go through some examples here. These are some strong answers that I read in this part 2, and I really appreciate the folks that did this from, and I don't remember who these came from, but I read them and I just copy and pasted them into a PowerPoint. So this is an example of including some empirical evidence to support a statement. Running economy is steady state of oxygen consumption at a given constant speed. I may not have copied and pasted that right because of the formatting, and includes a reference Conley. This is a great way to demonstrate that you are diving into the literature on this area. And now this is just a definition, right? But you'll find that when we start writing papers from your thesis or dissertation, almost everything needs a citation. So definitions especially often need a citation. So this is a great way to include a reference. Notice that you don't need to talk in depth about the citation. You're simply providing it as a supporting reference for this definition. And believe me, running economy is a term that is defined lots of different ways. This is a very commonly accepted way to define running economy. Here's a second bullet. If we look at figure 1 that was found in Noakes's law of running, we can see a graph for running economy where speed on the x-axis is in kilometer per hour. And on the y-axis, we see the rate of oxygen consumption in mLs of oxygen per kilogram per minute. Okay, I included this bullet here because anytime you present a figure, you have to have text explaining that figure. And the best way to go about explaining a figure is to say, here's what's on the y-axis, here's what's on the x-axis, and here are the data that are illustrated on this figure. That's just something that you want to get into a habit of doing, even in a presentation, because you want to guide your audience either in a presentation or in a text prose type answer. You want to guide your audience that in terms of what is being illustrated on the figure. So just say, here's what's on the y-axis, here's what's on the x-axis, and here's the data that are plotted. Okay, here's another one. I like this bullet. In figure 2, we can see a graph by Hurljack, 1993, depicting the energetic cost of locomotion at different speeds. So, always try to use a particular citation format. So follow APA or AMA. AMA is the number system, APA. And there's different formats for inline text as well as references. So it's good habit to always try to do that. And here that 1993 would be in parentheses. But what I like about this is this demonstrates that whoever wrote this went beyond the textbook, went beyond the lecture notes, and actually found a primary source from Alan Hurljack. I know Alan. Actually worked with him a little bit at University of Oregon during my PhD work, and he was a visiting faculty member. Super nice guy and really well knowledgeable in the area of gate transition. In any case, this is a really great way. One, you've found another figure that supports the information in the textbook. And then two, it's from a primary source paper, and it just demonstrates a deeper level of knowledge on this area. All right, the next bullet I have, for instance, previous studies have shown endurance training reduces skeletal muscle contractibility. Okay, and what I like about this is, again, whoever wrote this included some other references, Fitz, Widrick, but this is coming from the textbook. So what I want you to do for future is to go find those primary sources and be sure you read them and see if you agree with what Noakes has here. All right. The other thing I want to do to make this a stronger answer is try to avoid quotations. Quotations are great when there's a particular wording that is very critical to use. And then you want to give credit for that use or that sentence structure, if you will. What I want you to do is to minimize the use of quotations and paraphrase. Paraphrasing actually leads to a deeper understanding of the topic. And so to paraphrase this sentence, what you would do is go look up the primary source from Kostal in 89 and Widrick from 96, both the papers listed there, and then write your statement based upon the readings of those three papers. All right, so really good in terms of looking beyond Noakes, but make this a stronger answer and avoid quotations, and then go and read those primary sources. What my rule is, anytime I'm working with a student on a paper, if you include a citation, you actually had to have read it. All right. So you can't put a reference in your paper or in your reference list unless you actually have read the full paper, not just the abstract, but the actual full paper. So that's a good rule of thumb to follow. And the reason why that's important is because some people have misquoted and misrepresented certain papers along the way. The following graphs found in Chapter 2 PowerPoint were adapted from Falls and Humphrey, 1976, MSSE. And again, follow best practice for APA. I always say, start with APA, American Psychological Association, citation format for how to cite in text, and then also as a reference list, and provide a good example of the unique parameters, and then this sentence continues. What I like, again, about this is when you're taking material that's covered in class, and now you're finding additional material that's directly related to them. That's excellent. That shows a deeper level of knowledge in that area. So I really like that approach, and I'd like to see more of that as we do Part 2, Exam 3 of part two of exam 3. All right, so these are some really good ideas on and examples that you folks have done for this exam. Now I want to continue that forward for the next one. Here's a couple of other ideas, and I really like this, both of these as well. The first one on the left, these are from two different answers. The first one is on the left, and this is from a different Noakes paper, not the textbook, and provides more information about, in this case, the biomechanical model. Excellent. That's showing a deeper level of knowledge that you have and that you're finding on a particular topic. In this case, this pertains to the first question of part 2 in terms of the different models. Great to go and find other examples of that, and great to find primary sources, in this case, Noakes' work from 2000. So that's a really good way to go. I like the graphs on the right because these are hand-drawn, these are sketches, and they're representing other work. This answer would be stronger, or this figure would be stronger, if you even include a citation reproduced from, and then you have a primary source. You know, my lectures are great, Noakes' textbook material is great, but try to find the primary source information that corresponds with these figures. I love the hand-drawn part because it's showing me that you're taking a deeper level of trying to answer a question and demonstrate your level of knowledge. And by drawing these out, it actually does really help out. So this is really good. All right, these answers were included, and I just pulled them from different exams, and we can strengthen these answers. All right, these are good approaches, but I want to strengthen them. The first one, and I've already talked a little bit about this, is try to avoid quotations. All right, quotations are great because it does show me that you're reading the material and you're picking out appropriate information. But I want to see the level of knowledge that you have. And you do that by taking this type of quote and then paraphrasing it. Put it into your own words. And to paraphrase, often what you need to do is read beyond the material that's provided here in Noakes'. So look at any of the material that he cites and see if you can go read that, and then come back and rewrite this sentence in your own words. And again, that helps me identify your level of knowledge of the content. And what you also want to do in this next bullet is make sure that each sentence is complete. In technical writing, it gets a little boring to read, and sometimes the sentences seem redundant, but without the information in the sentence, it's sometimes that sentence really loses some context. So here, factors are age, gender, fitness and training, altitude, and ventatory muscle action. Two things on this. One is make sure that you fill in the information that these factors are influencing. So for example, I think in this area, they're talking about either VO2 max or running economy. I don't remember which answer it was, but it may be a sentence like that you have to add in, running economy is influenced by factors such as, and then you list them here. So that's one thing. Make sure that the sentence is as complete as possible. It's almost as if each sentence needs to stand on its own. And in technical writing, that's that. Sometimes things seem redundant or overly accurate, but it has to be very technical to be able to for the reader to get the right information. And we don't accidentally read it to mean something else. The other thing that you can do in this type of answer is include a citation or citations. And I say citations because each one of these factors may actually be a different citation. So you may say factors that influence running economy, I'm just filling that in, include age, and then include a citation, gender, include a citation, fitness and training, include a citation, and so forth. That demonstrates a level of knowledge of the topic by looking at the primary sources. And remember, you got to read each one of those papers. And I know that this is information that Noakes covers in his textbook, so that certainly helps. But I want you to continue to dive into the primary source information because I want you to understand this material deeper than what Noakes even does. I don't want you to rely just on Noakes. I don't want you to rely just on what I've presented. I want you to be critical and really evaluate the material that's out there and come to your own conclusion, which hopefully is the same, but may not be. You may see things very differently, and that's okay. That's how we move science forward. The third bullet I included here, muscle mass peaks around 24 years old and falls by about 10% around 50 years old. I love this type of information. This is great. Now, how do you make this answer stronger? Include a citation. Which primary source or sources did this information come from? Go find that primary source if it's referenced in Noakes's work and see if it's accurate. See if he actually represented this information correctly. So take this type of answer and take it to the next level and demonstrate that you're not only understanding the material and learning the material, but you're also relying on empirical evidence and research from primary sources to create an answer. Okay, I hope that's helpful. I'll tell you that the part 2 for exam 2 was overall much better than exam 1, part 2 exam 1. And that's good. You know, it's all about feedback. And hopefully this feedback is helpful for you to be successful for the next part 2 and ultimately to be successful for the final exam. Okay, thanks everyone. And as always, set up a one-on-one meeting if you want to talk through anything, or join the regularly scheduled WebEx meetings and come on and ask any questions and be glad to talk about this for your exam specifically. All right, thank you.